Hi, welcome back to another physics class with Domoji Maths and Science. In today's lesson, we'll be looking at linear expansivity. I will introduce the concept of linear expansivity and thermal expansion, and we'll use a question to understand it better. That said, let's get into class. If you have a rod, and this rod is being heated up, if I decide to heat this rod up with heat, if this rod has an initial length L1, this rod will definitely increase in length when this rod is being heated, and we'll have a new length for this rod, and let's call this new length L2. Now, for this rod to have increased with heat, that means the temperature of this bar has changed from temperature θ1 to a new temperature θ2. It was at an initial temperature of θ1 and it's changed to θ2. We'll call the change in temperature, we'll call it delta theta. That's a change in temperature. And let's call L2 minus L1, let's call it a change in length delta L. Now this delta L, the change in length delta L, is directly proportional to the change in temperature, and also delta L is also proportional to the initial length L1 of the rod, so that we can say that delta L is directly proportional to delta theta and L1. So that at the end of the day, we can say that delta L is equals to alpha L1 delta theta. That is where alpha is our linear expansivity. So that I can conveniently say that if my delta L is L2 minus L1, we can say that L2 minus L1 is equals to alpha L1 delta theta. So that L2 now will be equals to L1 plus, taking L1 to the other side, alpha L1 delta theta. So that L2 now will be the same thing as L1 into 1 plus alpha delta, with 1 plus alpha delta theta, all brackets. Now with this, we've seen why L2, which is the final length of the rod, is equals to L1 into 1 plus alpha delta theta. Let's look at some solved example. Let's take some example. Our first example says that a copper rod whose length at 30 degrees Celsius, that is θ1 is equals to 30 degrees Celsius, and at this 30 degrees Celsius, L1 is equals to 10 meters, is heated to 50 degrees Celsius. That is θ2 is equals to 50 degrees Celsius. And find the new length. The new length is L2. That's what to look for L2. Now remember that our L2 is the same thing as L1 into 1 plus alpha delta theta. Now my change in theta is given as θ2 minus θ1. So that θ2 minus θ1 is equals to 50 degrees Celsius minus 30, which is equals to 20. Now 20 degrees Celsius. Now if my change in theta is given as 20 degrees Celsius, I can now solve for L2. My L2 obviously will become L1, which is 10 meters, into 1 plus alpha, which is equals to 0.000, that's 4 zeros, 17 into 20. All. So that L2 now will be the same thing as 10 into 1 plus 0.00 times 20, that should be 0.00034. Now that's plus 1. That's equals to 10 into 1.00034. So that L2 now will be the same thing as 10.0034. So that's my new length. So the new length of the rod will be given by 10.0034. Now let's see our second example. My second question says that if iron rails of 8 meters long are laid close up end to end, the temperature is 30 degrees Celsius. Now, that is the initial length L1 is equals to 8 meters and the initial temperature θ1 is equals to 30 degrees Celsius. What gap will be provided between consecutive rails when the temperature rises to 60 degrees Celsius? That is, my temperature or final temperature should be 60 degrees Celsius. So that the change in temperature is equals to 60 degrees Celsius minus 30 degrees Celsius, which is equals to 30. Now the initial length L1 is equals to 8 meters. Now L2 we know that is equals to L1 into 1 plus alpha and a change in temperature. So that L2 here will be equals to L1, which is 8 meters into 1 plus alpha will given to be 1.2. The linear expansivity of the rod is 1.2 times 10 raised to the power minus 5. Now will be into the change in temperature, which is 30. Now that is L2 will equals to 8 into 1.0036. Now times 8. So that my final length is equals to 8.0288. Now the change in length will be given by L2, that's the change in length, will be given by L2 minus L1, which is equals to 8.0288 minus 8. That would equal to 0.0288. So in meters. So with this, we've come to the end of this lesson. If you have questions, please do not hesitate to use the comment section. Thank you for staying with us and see you in our next class. Thank you for staying with us and see you in our next class.